Good morning, everybody. My name is KerrireForster, and I'm the Chief Executive Officer of the Workboat Association. Today, I welcome you on behalf of the Commercial Marine Network, in partnership with the Maritime Journal and Seawork, and in association with the Workboat Association. The event is supported by the Society of Maritime Industries, the UK Harbour Masters Association, and the UK Maritime Pilots Association. I'd like to express our thanks to our Session 4 sponsor, Custodi of generations of experience in waterjet engineering design. And as an experienced boat builder, Custodi can also bring to the table installation know-how, advice, and support to all their customers. The Custodi waterjet is the only system to offer an integrated gearbox, providing very compact installations and both weight and space-saving opportunities. The benefits that can be obtained in terms of weight reduction, combined with high efficiency of the Custodi waterjet, grant a reduction in fuel consumption and consequently in emissions. Custodi are confident that they offer both considered design and superior engineering for all waterjet applications. Today is the fourth in our events, and we'll be discussing medium term from 2025 onwards. Vessel design and technologies for the future. Focus on propulsion system machinery, including hybrid battery and electric, and the use of SCRs. Today, we have far gone any expectation of registration numbers, and I believe we have pushed our attendee quota past its capacity, with over 500 people registered today. It has been fantastic over the course of this series so far, to learn so much from so many enthusiastic and experienced people. These events continue to spotlight incredible technologies that share unmissable lessons learned across the global industry. I would like to thank all the people who make these events happen, including the Commercial Marine Network team, our long-term moderator, Andy Page, and the series stakeholders and sponsors, all our speakers, and of course you, the attendees. Registration rates are increasing rapidly with each event, which makes it clear to see that these sessions continue to be a must-attend program in everybody's diaries. Andy, our moderator, will join me in just a few moments to introduce to you our fantastic panel of guest speakers. But before he does, there are some functionality topics to discuss to make sure that your experience joining today is as comfortable and as interactive as possible. Today's session is being recorded, and it will be made publicly available after today for you to share with your colleagues and friends and to watch back yourself. There is a public chat function available to use throughout the section, which we welcome delegates to make any introductions and comments, but please do not use this chat function to ask the questions. There is a private chat function. If you have any issues or any comments to the host, please do this in the private section of the chat box. This allows you to send messages to specific people. Admins for the session will also be listed here. And finally, the important questions and answers box. We will give the opportunity for delegates to ask questions to the panel at the end of the session. This feature is found next to the chat function, so please type any questions in here throughout the event, and our moderator, Andy, will read these out to you at the end. If you're directing any question to a specific speaker, please make sure you provide the speaker's name in the question. And remember, there are a higher number of attendees today, and we will try and collate as many answers to the questions as possible within the session, but we apologise if it's not possible in all cases. You should be able to access contact information to all today's speakers, and if we cannot answer your question today, please do make contact directly following the event. Handouts related to today's presentations are available to download at the top of the chat box. And if you're using a mobile phone or tablet, please note that some of the functions may be hidden, but they can be accessed by clicking a blue speech bubble icon. So, here comes Andy. Without delaying the event any longer, hopefully I've met his criteria of giving more detailed introduction to today's event, and I'll pass you over to Andy Page, owner and director of Chartwell Marine Naval Architects, our series moderator. Thank you very much.
Thank you very much, Kerry, and good to see everyone today. As Kerry said, we're very grateful for the number of attendees that we have, and great to have set this webinar series up and to see so many people enjoying and learning from the great speakers we have. And I hope that we're not going to disappoint today. Today, as Kerry said, our theme is on future propulsion systems and supporting battery technologies. And to support that, our speakers come with both experience and actual case studies for us to learn from. So I'm going to invite our first speaker, Tom Binns, to turn his camera on, hopefully. So Tom is the sales manager for MIT. MIT have a strong background in mechanical power transmission solutions within varying markets, from marine to agriculture to automotive. This varied industry knowledge provides unique understanding of challenges and demands of different drivetrain assemblies and how these power requirements translate to decarbonisation for maritime projects. Tom's presentation today, MIT call MIT Insights, and what the presentation represents is why integration is key to maximising performance and return of investment for zero emission and low carbon projects through complete system integration and vessel understanding. As it reads here, as the market continues its progress towards decarbonisation, it is essential that early adopters are successful in delivery of the best performance and return on investment available for their vessel. In this session, MIT are going to explore the key drivers of successful and profitable drivetrain integration and focus on decarbonisation. So Tom, if you could turn your presentation on, I will hand over and look forward to hearing. Thank you.
Okay, thanks, Andy. Morning. So yeah, following that fantastic introduction. So yeah, MIT are a system integrator, supplier, and an aftermarket partner for marine and off-highway propulsion systems. For the last 5 years, MIT, along with a number of our manufacturing partners, have been involved with marine and electric hybridization. Through these, we've evolved and developed our approach to the delivery of vessels and vehicles that we feel deliver true value to their key stakeholders. The key stakeholders in the success of the project is the integration of the system and a holistic view of the vessel and its operations. So what is an integrated approach? So an integrated approach is one that starts by looking at the vessel and its requirements to its key stakeholders. So these can be from performance to its functionality. So the approach begins with a holistic view of the vessel and its requirements, and it starts by looking at the vessel and not the technology that we're trying to implement. With a clear and accurate understanding of all the requirements and considerations for the project at the start of the cycle here, it allows us to be more successful as we follow that development cycle through. And that success comes in a number of ways. It comes through the minimization of cost, of weight, of disruption to the vessel, but it also comes with the optimization of the savings in CapEx and OpEx that are offered to the users. There are three main types of electric and hybrid propulsion systems. So we start at the furthest left. There's a fully electric application. So this is driven by electric only. The electric can be generated in a number of ways, currently with battery technology, but also moving on into hydrogen and other fuel sources. In the center, there's the series hybrid option. Now this is where there is an electric motor which is used solely for propulsion, but the source of that electricity comes from a number of different sources. So that can be from a battery bank or hydrogen cell. It can also then be a range extender type generator set, or in what is traditionally used at the moment as a diesel electric set. Then there is a parallel hybrid system, which I think is what is currently seen in the market as a hybrid option. So parallel hybrid is where mechanically the whole system is as one, and the system then chooses which energy source it is taking from and driving from, depending on the application it's doing at that time, the load point, and a number of other factors. All three of these systems offer a move in the correct direction, but they all suit different applications and they suit different loading profiles, which we'll come on to shortly. So one of the key considerations when we look at what the vessel needs to do and what we need to do to make the vessel feasible. Some of the key aspects when we look at feasibility and ROI and a project can achieve is its operating profile. So whilst reviewing the operating profile in combination with other factors, then suitable propulsion technology and the correct energy storage solution can be identified and optimized for this particular application. The operating profile of the vessel comprises several factors, including the duty cycle, the loading profile, and the percentage utilization of the vessel. While some of the elements are easily quantifiable, the loading profile is the one that often requires further study and often logging. The duty cycle is often relatively easy to say. It's often a timetable or it's an operation that's known. The utilization, again, it's ordinarily and easily quantifiable. One of the main challenges that we find facing, especially UK operators today, is actually the final piece on this, which is the availability of the electrical infrastructure. In many instances, the most difficult obstacle to overcome is the limitation of the power available at the operating site. And through the development of energy storage technologies, there are increasingly ways to overcome this through the different technologies and through different partners that are available to offer the infrastructure side. Through consideration of all these factors, you end up with the best possible product with the minimum investment. But the project is shaped by all of these, and all of these need to be understood. The better the understanding, the better the outcome. And at the end, you end up with the correct system specification that will deliver the best results to its operators and to its stakeholders. This is an example of one of the operating profile logs that was taken. So this is actually taken from a tug and doing vessel operations. Doing port operations. As you can see, the bars represent the hours at different engine speeds and effectively load points. By understanding this better, we can look at where the areas of utilization are. We can see where the inefficiencies are with the different types of systems and where the efficiency gains can be made. So this contributes to our system design, and it also contributes to our system type that we choose, along with some other factors such as the environment, draft, things like this. So as you can see in this application, much of the load is at a very low level. So when we take that at a low level with minimum peak performance, then what we do is we run that through effectively a matching process, which is shown on this one. So this matching process is where we look at where the vessel spends most of its time, and we look at what savings can be made at these different load points. We can also take into consideration the amount of energy storage that we actually need on the vessel. And in most of these projects, the energy storage and replenishment of that energy is the key factor. So by getting this balance right, where we transition from an electric power to a diesel, and then up into the boost range. So this allows us to give the maximum return on that investment by meaning the operating costs are the lowest we can make them, given all of those different factors that we've considered. So whilst the propulsion system is the main focus when we look at electrification and hybridization initially, actually there are a lot of wider vessel considerations. So the vessel is not just there to be propelled, the vessel is actually there to do a number of other things, and all of these other functions draw on that energy that we've got stored. These include the deck-mounted equipment that can be on there. So these are cranes and other items. HVAC, when we look at the hotel loads, specifically probably in the ferry market and the cruise market, the electrical systems that are on board doing numerous things. And as technology increases, these electrical systems only get more burdensome. Also water systems. So these can be ballast systems on larger vessels. These are also looking at the likes of dredging systems. So where we've got dredging pumps that are running and high loads that come on and draw from our energy storage. So only by ensuring that all of these parts are optimized and considered from the outset can you make sure that the vessel does what it's designed to do, specifically to its operators at that time, and the vessel is actually adopted by those operators and it's championed and the whole project is moved on. One of the pieces that is also not considered, or I don't think it's apparent at the start of the cycle, is that actually these vessels go into operation for 15, 20 years. And part of that operation, or part of that operating cost, is how they're supported thereafter. So that's with the likes of having the availability of parts, of service engineers, of having upgrades to systems. So as the technology moves on, undoubtedly these systems get upgraded. So we move from a first generation motor, controller, battery, we move that to a second generation. The core of the product hasn't changed, but actually by bringing in these upgrades, it means that the vessel can move with the times, and you're not looking in 4 or 5 years' time at a vessel that basically you are now looking at another repower, a considerable capital expenditure once again, and that return on investment stretches out through the lifetime of the vessel. The point at the bottom is also of importance, where there's monitoring and proactive maintenance and scheduling of parts can be done. So where largely our operators of these vessels see the return is through the reduction of their operating costs through fuel. But if we can't guarantee the uptime of these vessels, and actually we're seeing that the uptime is diminishing, that return is almost wiped out by off-charter fees or by offering replacement vessels. So the monitoring and the uptime is key. So making sure that when you look at a solution, is there a whole life support package available for that solution? And is there somebody who is going to look after that for you to make sure that vessel is operational as many hours as possible, and actually it can offer the maximum return from that investment that's been initially put into it. So once all of these aspects are considered, you end up with a fully integrated view of the vessel. This has allowed us to get the correct system specified from the start. It should deliver back what the operators, what the owners, and what the other stakeholders wanted from the vessel. It aids the architects and builders in knowing what is required of the vessel, what efficiencies are required from the vessel, what load capacities are required from the vessel. It allows us to deliver the system more quickly because a lot of the configuration can be done before it's even gone onto the vessel. We get guaranteed vessel performance because we've truly understood what the loading requirements was, how much energy we needed on board. It makes for a smoother installation, and we've got less risk of system modifications post-launch. Where we've not had that level of understanding, we've had to go back to vessels numerous times. The operator reports it can't go long enough, it can't go quick enough, it needs to do this, or actually there's a load that we didn't consider. So by having all of that done up front in the planning process, actually it reduces all of that post-launch modification, which is one, costly, and two, takes a lot of time. It optimizes the operator experience. So going back to Andy's introduction to the actual presentation, the operator experience in this is very key. The people who are willing to move forward, the early adopters, we need those as our advocates, and we need them to really promote the hybrid and electric movement going forward. So the better we can make that experience for them, the more likely they are to report as well. We also get a more seamless project delivery. And as I say, at the very bottom line, we get a better return on investment for all those stakeholders. And that is me.
Thank you very much. We haven't got much time, but I thought I'd just throw in a question real quick before we move on. As you say, everything is around the operating profile, understanding the application, etc., etc. So if a customer came to you and they said, I want to build a hybrid vessel, what sort of information do you think they would need to bring to you as the system integrator?
So they need to bring as much as possible, is the long and the short of it. If we're doing a repower on an existing vessel, actually that's one of the ideal, because we can look at that existing vessel, we can look at what it's doing. I think the expectations of that vessel are quite well known. So if they bring to us what that vessel is, what the expectations of it are, what equipment's running on it, and like I say, the key one that we've come across more and more is actually, how are you going to get energy to this boat?
Mm-hmm.
You know, have you got infrastructure? Have you even considered what's on the shore?
And on that note, real quick, is there, are we lacking in infrastructure? I assume we are.
Yeah. So if you talk across Europe, it's not a consideration on a number of European projects, because they say, well, you just put a charger there. There's plenty of chargers available. There are. But when you try and move that into a UK application, you find the UK grid is actually really quite poor. And especially in some key areas, London being one, that, the grid is really poor in those areas. So the grid considerations are a big one. There's a lot of technology that's now aiding overcoming that. But like I say, the advent of hydrogen and a few other bits are really helping that as well. It's an important consideration, is the shore side, not just the vessel.
Okay, great. Right. Well, I think we'll come on to that more in panel discussion later today. So thanks very much, Tom. Thank you.
No problem. Thanks, Andy.
Great. So next up, we have Simon. Thanks, Simon, for joining on the camera there. So Simon is the Operations Director of MSC International. Simon has a broad knowledge of the marine and maritime sector, having gained a long career, 18-year career as a professional seafarer, of which spent 16 years developing and running UK and EU collaborative projects. So Simon today is presenting on 3 topics: the need for the electrification of shipping, the MARI UK Clean Maritime Call, and finally the FLOMAR project, which I think everyone is going to find very interesting. It's a slightly different take on energy storage and power provision. Over to you, Simon. Really looking forward to your presentation.
Great, thank you, Andy, and thank you for being invited to speak in this event to what appears to be a truly global audience. I think we've got participation as far afield as Western Australia, so that's excellent. So what I am, I'm from Marine Southeast, actually recently rebranded to MSC International, and as Andy said, we create and facilitate innovation projects with our stakeholders in the marine sector. And I'm talking about the feasibility of using flow batteries in zero emissions shipping. So just before I do that, so Tom spoke about electric propulsion in vessels, and that they clearly need a source of electrical energy. One of those is batteries, and so my talk is about a redox flow batteries, which is a type of battery in battery chemistry that has yet to be used in marine applications. So the project that we've completed now, looking into the feasibility of flow batteries, the consortium had 4 partners: Swan Barton, who are energy storage consultancy and experts in flow batteries, ourselves at Marine Southeast, Holder, who many of you may know, who are marine architects and a clean tech consultancy, and Lloyd's Register Classification Society, that I'm sure even more of you will know. So what I'm going to cover in the short time I have available is just a few words about the electrification of shipping and boats, flow batteries themselves, and then the findings of the activities and findings of the FlowMar project itself. So, as we all know, shipping is looking at the options for decarbonisation, and one of the most popular routes to achieving that is through electrification. Perhaps through using a hybrid system with an onboard battery, but not charging from port. A plug-in hybrid, where the vessel takes a certain amount of charge from port facilities where they exist, or the fully electric option, where recharging is done when the vessel is alongside, using battery types such as, typically at the moment, lithium-ion batteries, but there are other options, flow batteries, and of course hydrogen fuel cells can be used too. So lithium-ion is the market leader at the moment, but we were intrigued about the advantages that flow batteries might be able to bring to maritime applications. So if this is a real event, I'd ask people to raise their hands to say how many people are familiar with a flow battery, have heard of a flow battery, know what it is, but that's rather difficult. So I will assume that people don't know much about a flow battery, and we'll just give a very basic overview of a flow battery and how it works. So it's a rechargeable battery in which electrolyte flows through one or more electrochemical cells from one or more tanks. And key to the characteristics of a flow battery is that the energy storage capacity can be increased by increasing the volume or number of these electrolyte storage tanks. And the cells in the middle, they can be connected in series or in parallel, so determining the power of the system. And those two things, the power of the battery and the energy capacity of it, are decoupled, they're separate, which is a key characteristic of flow batteries. So unlike with the lithium ion system, if you want more capacity, you need more cells, so you increase both the capacity and the power. So the conversion of energy inside the cell between electrical and chemical energy, or vice versa, takes place in the cell, which consists of two half cells separated by an ion exchange membrane, and that allows the ionic conduction and minimizes the loss of the generated electrolyte species in the half cells, maintaining efficiency. And the redox reaction takes place at the electrodes, which are themselves not altered by these redox reactions. So some particular advantages and challenges of the flow battery. As I've already mentioned, there's a separation of power and energy. In a marine application, tanks can be designed to suit the shape and trim of a ship, either one big tank or a number of smaller tanks distributed where as convenient. The battery can be recharged electrically in a sort of conventional method by having a cable or some sort of charging infrastructure to shore, but particularly they can be recharged hydraulically. So replenished electrolyte that has perhaps been recharged in facilities ashore can be exchanged by hydraulic pumping onto the vessel, potentially allowing for very much faster replenishment of the energy store on the vessel. There's no fire risk or thermal management issue with the flow battery chemistry. They're characterized by low cost components, long life, and all the elements are recyclable, and there's no dependence on rare earth minerals. But there are a number of challenges. The flow battery typically has a lower energy density than an equivalent lithium ion battery, perhaps 50 to 80% of a lithium ion solution. The most common flow battery systems are based on vanadium, and they have the electrolytes are acidic, so there is a consideration there. Future electrolytes, which are based on organic chemistries, promise improved energy density and good environmental performance. So we, as I say, we're intrigued by the possibilities of flow batteries for marine applications. Marine Southeast, we put together the consortium, the 4 organisations I mentioned earlier, and applied to marry UK's Clean Maritime Call, and were successful in getting grant funding of £69,000 to half fund the project. It was a 6-month feasibility project that completed a couple of months ago. And the aim of it was to assess the feasibility of using a flow battery to enable zero emission propulsion and or auxiliary power in maritime vessels, and to pave the way to de-risk further development and leading towards a physical demonstration of a pilot flow battery in a marine application. So we haven't been able to do that yet. That's hopefully the next stage. So we looked at potential vessel We looked at potential vessel applications, starting with 15 candidate vessels that, having looked at their operating profiles and their basic GA, we looked in more detail at those 15 and refined that down to a short list of 3, which were two ferries and a product tanker, where we did more detailed modelling. And out of those 3, there was 1 harbour ferry where we did more detailed work and defined did a new general arrangement and did the stability calculations and more detailed investigation of the use profile. So those 3 vessels we looked at, one was a red funnel ferry, so that's a ferry that runs between Southampton and Cowes on the Isle of Wight, and that would lend itself with a flow battery to being recharged hydraulically, because it has a regular but short berthing time on its journey between Southampton and the Isle of Wight. The MV Thames Fisher, that's a product tanker. The application for the flow battery there wouldn't be for its main propulsion, but would be a flow battery system housed in a new deck house that will be used to power the cargo pumps, which have quite a chunky load requirement. But the vessel we focused in more detail on was the MV Harbour Spirit, which is the harbour ferry that shuttles between Portsmouth and Cowes. So Portsmouth and Gosport in Portsmouth Harbour. So they outlined concept design for the harbour ferry. It's a 32-metre harbour ferry. We reassessed the weight and stability and reviewed the configuration of the flow battery system, completely replacing the conventional diesel propulsion that's currently fitted with. And because of the duty cycle for the ferry, it requires higher power to be available during manoeuvring and berthing operations. And the optimum solution for that was to incorporate supercapacitors into the design, essentially making a hybrid system. But the end result was that the outline design with a flow battery would meet the operating requirements of the current system. Lloyd's Register did a design risk screening exercise and didn't identify any high risks, and the provision of backup power would depend upon the particular circumstances of the vessel that's operating. So to conclude, we found flow battery propulsion can be integrated into the design of vessels. The electrical propulsion system itself can be of a conventional arrangement. There are no serious safety issues. There are the options for electric and hydraulic recharging. The early adopter markets for flow batteries, as with most things electric, are vessels with more limited power and energy requirements. There are lifetime savings in maintenance and the overall costs of ownership likely. Clearly zero emissions at the point of use, and the use of a flow battery vessel can be incorporated into energy storage systems.
Simon,
Yep.
we're going to keep it there. Thank you very much. And we'll continue on in the panel discussion. So thanks very much, Simon. Thank you.
Okay.
Torleif, if I could invite you to join on the screen. Great. So our next speaker is Torleif Stokke from Servigear AS. Torleif is the managing director. He's graduated with a degree in marine technology from Bergen University. And has held several positions in Wärtsilä over the years. Worked for Servigear since 2011, and is going to talk to us today about Servigear's hybrid propulsion solutions. So, Torleif, if I hand over, thank you very much.
Thank you very much for the introduction, Andy, and also it was good to listen to the two other panel presentations. We see we are working more or less with the same challenges. So I will go over to what we are doing. Okay, what is Servigear doing? We are doing propulsion systems for high-speed operations, and it's based on the variable pitch technology. We are helping our clients to reduce their fuel bill, giving more money on their bottom line. And this is done by optimizing the efficiency of the propulsion systems. We have seen cases of more than 30% reduced fuel costs. And when the fuel bill is close to 50% of the vessel's OPEX, it makes sense to reduce it. Going towards zero emission. The efficiency of the hull and the propulsion system is the enabler for making this happen. The energy consumption is kept to a minimum, and this is even more important when zero-emission technology is implemented. The key word is energy storage capacity, whether it's battery, hydrogen, ammonia. The common challenge for all new fuels batteries is a very low energy density compared to diesel or gas. When this is said, constant improvements are taking place, and it's mostly driven by the car industry. And also remember Simon's presentation of the Flowmar batteries, the flow battery. So a lot of technology development is going on around. So let's move to Norway. 11 out of 13 hybrid or fully electric hydrogen high-speed vessels built in Norway are already operating or are under construction with Servigear equipment on board. Many of them as world's firsts with new technology. So let's have a look at them. The first one, which you see here, is it's actually two vessels, and they have been operating as hybrids since 2018. They are connecting the citizens of Røver, an island offshore Norway, to the main city Haugesund, 30 minutes en route. And using the battery power in the harbor areas and the diesel engines in the open sea, they have been successfully operating for 3 years. The result? Reduced emissions locally, reduced fuel consumption, and reduced maintenance on the main engines. This is also the world's first commercially operated fast ferries on hybrid technology. And now, both of these vessels actually will be commissioned with bigger battery packages and electric motors only. Note that the propulsion line is kept unchanged. The vessel will then operate fully electric under the same contract as before, but with zero emissions. This vessel is part of an EU-funded project with partners from the UK, Norway, and the EU. The aim for this project is to develop a module-based zero-emission design. which in turn will lowering the production costs of the vessel and also giving increased flexibility for different vessel applications. She will replace a traditional fast ferry operating the islands nearby the city of Stavanger with the same schedules, fully electric and charged at the quayside. This slide, I won't go through it, but if you remember the presentation from Thomas Binns, this is some of the factors to consider when planning the overall system functionality and capacities. And this one is on the handout, so if you want to have a closer look on the operation for this vessel, you can have a look on this later on. And the next slide. This vessel is quite interesting, actually. This is a Sunseeker Predator, 95 feet. By the way, it was formerly owned by the Libyan dictator Muammar Gaddafi. And for various reasons, he doesn't need it anymore. So now it's in for a complete makeover back in Norway. It's renamed to Hydrogen Viking. It aims to be the first yacht being able to cruise north of 30 knots. And the only emission would be pure water, which you can mix into your drink. The propulsion line efficiency is improved, and the installed power will be roughly 2,000 kilowatts to reach 35 knots. Last but not least, let me draw your attention to high-speed transfers, HST Ella and HST Frances. These are two sister vessels bound for the operations in the wind farm business of UK and France. The hybrid technology is based on the experience and learnings from the 11 projects already done in Norway, as well as an extensive R&D work over the last decade. In addition, we have the experience and learnings from soon more than 90 vessels operating servo gear technology in the wind farms. We are honored to partner up with Tom and his team in HST to finally implement low-emission technology to the wind farm business. And here I would also mention the designer of the vessels, Andy Page, which is heading the panel today, and you have heard from already. Great job here, Andy. Well, the common factor for all the vessels in the servo gear is the servo gear E-flow propulsor, where the already strong efficiency of the EcoFlow propulsor have been further improved when going electric. Servo gear's contribution to the strive for zero emission will be to always focus on the reduced energy consumption. This saves money for the client, both CapEx initially and OpEx during the lifetime of the vessel. And this is done by having a holistic view on the system and operation profiles together with the owner, the designer, and the shipyard. It's not one component alone that ensures our success. The big secret lies in the success of making all the details working together. I'm soon about to touch down with my presentation, so I would like to share some of the key learnings which we have experienced during our years with in the strive towards zero emission. And the first one, the electric motor in combination with the reduction gearbox gives in a total a reduced weight and also very much reduced capex. And the reason for this is the reduction of the size of the electric motor. The alternative would be to connect the electric motor directly to the propeller shaft. But due to the low RPM needed for get an efficient propulsion system, you would have to put there a very big and heavy electric motor to take care of the forces needed. So that is a total money saver. And the other one, which is even more important when going towards zero emission, is to design a 15% more efficient propulsion system rather than buying a 15% larger battery package. This gives also a strongly reduced capex. And this will pay back in reduced OPEX every year. And don't forget about the weight issues with the batteries. So, as said before from Tom, and I would repeat it, to focus on the entire system as well as the components is of great importance for success. So we can help you with the efficient solutions if you're interested. So feel free to contact us. You have on the last page of the handout, you have our contacts. And then I would just, when I sum up everything, also mention that we have some partners in crime. We have our service partner in the UK, MIT, which you already have heard from. And as said, you always need someone to cover up with the feet on the ground. So our long relation with MIT enables improved service to our valid customers in the UK. Thank you for listening.
Thanks.
Maybe we see you at eWorks.
Thank you very much. So, Torleif, if you can stay on the screen, and I'll invite Tom and Simon to rejoin. Simon, are you there as well? Great.
Yeah.
Cool. So thanks very much, everyone. Simon, I thought, apologies for interrupting you there. I thought if we start with yourself, you were mentioning requirements to take the project forward. Can you just let us know what those are?
Yes. Well, we need to actually get to a point where we're using a flow battery in an actual pilot installation. So the cells themselves, although the technology isn't new, but it is evolving greatly, but it's only been applied in static applications in power stations and the like. So we don't have any feel really for the impact on the functioning of the cell from shock loading, for example, in a small vessel. So there's quite a lot of development and investigation work needed to see if a flow battery cell is robust enough, or what modifications need doing to make it suitable for marine application. And so we're looking towards building a consortium with the right expertise and capabilities to do that. So I say the Flowmar project was a 6-month feasibility project, and out of it, we believe it is feasible, but the devil is in the detail, and that's where we need to get next. So a bigger budget, a longer, probably a 2 or 3 year project to actually put something on the water and get the baseline data that it actually is a practical solution.
Great. And Simon, to be clear, you're actively looking for consortium partners, etc., to bring this to.
Yeah, we've already actually have put in one application for funding, which unfortunately failed. Well, I think one of the evaluators is probably in the lithium-ion business. The other 2 were really keen, but that's how it goes. So yeah, we're busy trying to move on to that second stage.
Great. Okay, and Tom, Simon mentioned the use of this technology in industrial environment. Is there any learnings from your experience in agriculture and industrial that can be brought into marine?
Yeah, there's a number. Really, a lot of the technologies are really feeding down from, on highway is really seen that move on, and we've seen a lot of that now following off highway as well. So there is pieces of learning that can follow, but actually I think the main driver is the investment in the technology, and the big wins for the technology providers are those off-highway automotive applications. And what we're seeing is quite nicely a cascade down from those of actually the technology that's available to all of us for sort of utilization in what is more of a niche market for these sort of big players in technology.
Yeah,
Yeah,
I can just
I was going to say,
make an observation that we're moving towards an integrated energy system based around ports, really. So the vessels need the energy. The ports have their own energy requirements. Often they're good places for renewable generation, particularly solar and sometimes wind. They're also their customers. If they're a ferry port, for example, will often be driving electric cars, and they'll need facilities to recharge those. So there's a whole integration exercise going on with energy generation, energy storage, energy management, and all the technologies to make that work in a cost-effective way to decarbonise the whole process, not just the vessels.
Yeah, and in terms of, as you say, about the hydraulic pumping with the electrolyte from shore to ship and those kind of arrangements and the storage of this, do you see like tankers kind of delivering this to?
Yeah. Well, one of the proposals we're working up at the moment and actively talking to potential partners in a project is for a flow battery system in a large floating barge that could be moved around a port to provide the power where it's needed, when it's needed, either on a day-to-day basis or seasonally. The Norwegian leisure sector are very interested in providing electrical provision to their customers, but they're in the more remote locations. They don't have the grid capacity to do it. But a mobile platform that can be tucked away somewhere in the wintertime is quite handy to do. So there's lots of different solutions, but that's one we're looking at the moment. So a barge with tanks of electrolyte in it is not an expensive proposition, the actual barge itself.
Cool, and perfect segue for me there. Torleif, why is Norway so active in this space?
Yeah, it's a good question, Andy, and I think maybe it might be a bit historical. For one of the bigger industries in Norway for many hundreds of years, maybe as far as the Vikings, the sea, traveling at sea has been important. We are one of the world's greatest shipping nations in tonnage. Actually, this year, I think we are number 5. So that means it's a big drive, it's a big tradition, it's a kind of industry that we have had. So it's more a natural evolvement, I think, that we are constantly driving the technology, trying. And also we have, if we take just the last 10 years, we have had since the first electrical car ferry, MF Ampere, were put in operation as a demonstrator. There has been, I think now, soon 80 car ferries coming into the fjords and connecting the roads over the fjords, which are either hybrids or fully electric. And why? This is mostly the sourcing power, because the government owns the ferries and they put new requirements when the vessels are being ordered, and that drives the technology development a lot, because then the industry is, of course, doing this.
Yeah.
The next 10 years, the same is going to happen with the fast ferry operations in Norway. It's like 75 routes going to change contracts now the coming 10 years. And the government are now asking what is possible to do, what kind of technology is available, how big percentage of electrification is possible. And there are a sourcing power, and it's also comes some money from the government to let's say make this happen faster. So maybe that kind of answer
is important. Government engagement is important, both in terms of the funding, in terms of the regulatory framework, etc., etc. Yeah, we've had a lot of questions actually come up about regulation. Do you actively work with the class societies and with the flag states?
Yes, the flag state and the classification societies are very important to drag along during the whole development phase, because the rules and the regulation has to develop simultaneously.
Yeah, and Simon, I appreciate you're obviously in the early phase in terms of feasibility, but have you engaged with the MCA at all on the subject?
Not the MCA at this stage, but as you'll have noticed, one of the partners in the project is Lloyd's Register. So they conducted a hazard at an appropriate level for a feasibility study. So we're very much aware of we need to address the safety and environmental risk elements of any new application of something like a flow battery. So moving forward, that would be an integral and important part of the next stage.
Yeah, it's important both in terms of your understanding, but also to help drive technology, to help educate the regulator on what's going on, what systems are coming in, and obviously collaborate as much as possible.
Yes. Well, one point I would make, just referring back to what you were saying about the government involvement. In the UK, we work with the International Port of Portsmouth, who are a municipal port owned by the City Council. So the air quality of that, or the pollution the port is responsible for, is that the owners, the council, they're answerable to the voters and the citizens of the city, and that's proving to be a major motivator for the port engaging in a whole range of decarbonisation activities with a vigour that we don't really see so much in the private ports.
And is that similar in your ports you're working from, Torleif?
Yeah, also the port authorities have quite strict requirements, and it's all about the IMO goal about reducing the emissions into 2050. Everything is linked together in a global scale here. So all the nations have their goals, and then it drops down in the end to all of us in a way.
Yeah.
So I think it's more or less the same requirements in any nation.
Yeah,
and
quite.
of course, there is one interesting thing is that the wind farm business itself is a green business, but it should be even more premium for the ones coming in with green technology. I think the carbon taxes has been one tool which has been talked about for some years. So rules and regulation is also a driver. I think we need it globally.
Yeah,
to get to the goals. Yeah.
Exactly. There's a lot of work to do. I mean, Tom, from your perspective, how have your team have to sort of shift their, skill level? Are you moving more towards electrical engineers, from mechanical?
Yeah, so it's been a big driver over the last number of years, is probably bringing in more. We are now more involved in electrical engineering than we've ever been before. As you say, we've come realistically from a very mechanical background, and it's the pace that things are moving is quite hard to actually keep up with currently. And what we're seeing is those electrical engineers are becoming more and more in demand, and that's not just from marine, that's from across a number of different industries and sectors. So actually getting good electrical people is a real challenge, and we are having to put more into our apprentice schemes to try and help that. But it is definitely a struggle for us, but it's a move we're having to make slowly.
Yeah, and that's it. I mean, and looking just at the questions here, not to put you on the spot, Simon, but people, everyone is becoming more educated in the subject. One of the questions here is it relating to the density, the weight compared to lithium-ion battery. I assume it's higher.
It is. The devil's in the detail, depending on the precise chemistry you use and which lithium-ion battery you're comparing it to. But it's typically between 50 and 80% of the energy density of lithium-ion. But it depends what you measure. So as I said, if you want to store more energy, you have more tanks of electrolyte. But if you don't need more power, which is not the case with a lithium-ion. So there's, as I say, the devil is in the detail. But on a vessel, you could replace ballast tanks, for example, and the fuel tanks from a conventional vessel if you were retrofitting with electrolyte vessels. So, but it would be true to say it's more suitable at the moment for a displacement hull with a modest power requirement or energy requirement because of the energy density. Over time, that is expected to improve. But I think we're a long way from having a high-speed planing hull using flow batteries.
We'll get there, yeah, one day. Mindful of time, as ever. I wish there was more, but thanks very much to everyone today. Fantastic event. Thanks to Custodi for sponsoring. Our next event will be on 15th of June 2021 at 10 o'clock in the morning. As ever, a recording will be sent to delegates at the end of this presentation. Our next session is on the future fuel race, battery, hydrogen and ammonia. So thank you very much, everybody. We look forward to seeing you again. Thanks, Simon. Thanks, Torleif. Thanks, Tom.